Hi everybody, welcome to another Chats with Chaudhry. I hope you're safe and well. Today I'm delighted to be joined by Erica Forsberg, who is the Metabolomics, and I had to practice saying that, America's Market Manager for Bruker Daltonics. And we're going to be talking about some of the common challenges in metabolomics. So first of all, Erica, it's lovely to see you. Thank you for getting up early in the morning just for this call.
Thank you for having me.
So just to let viewers know, where are you calling in from this morning?
I am based in San Diego, California.
I should have put a Chargers or a Padres jersey up on my door then. I hadn't realized. And I'll be in San Diego next week as well for a show. So there you go. All right, fantastic. Well, look, before we start talking about some of the common challenges in metabolomics, would you mind giving viewers a quick overview of the business unit you work in within Bruker Daltonics and also your role and background?
So in the Metabolomics business unit, we work with mostly small molecules, mostly of biological origin. A lot of our experiments that we would help customers with is probably any kind of experimental conditions where you're looking at a change between a disease state or some kind of exposure, et cetera. So we help with the analysis of any small molecule metabolites that you would see within a biological system, and then go through statistical analysis and garner some kind of biological information out of that.
Right. And your role and background?
So my role and background is that I am the market manager. So I mostly liaise with customers and helping them with developing metabolomics workflows, helping them with instrument operation and ensuring that our timsTOFs are working properly and chugging along and giving lots of data to our customers so they can successfully get through their research projects. My background is I came from an academic position at San Diego State University. I was running my own research lab doing gut microbiome research. And I previously, before that, was in Gary Schuzdak's lab as a postdoctoral fellow for 2 years. And I did come out of a lab in Canada under John Brennan at McMaster University, where I did my Ph.D., where I learned all of my mass spec background.
Fantastic. So you are perfectly qualified for me to ask you these questions. Excellent. And my very first question is a really basic question, actually, as a layperson. What is the difference between metabolomics and the other types of omics out there? And, you know, what is it used for?
Well, we always like to talk about the dogma of biology, where you have genes to proteins to your small molecule metabolites, which then gives you the phenotype. So it's really just a size range. We're looking at small molecules that are below 1,000 Daltons, more or less, whereas proteins are typically well above that, and peptides, et cetera, are going to be a larger mass range. So technically on a mass spectrometer, that means a lot of your tuning parameters are different. A lot of the optimization that you would need to do for chromatography on the front end are going to be different. And it's a completely different world than genomics, where you use completely different techniques, where you're in the sequencing realm. Metabolomics becomes challenging because of the chemical diversity, where you're not just dealing with 20 amino acids or 4 nucleotides. You actually have to figure out what that molecule is based on knowing what's in your system.
Right. Well, that actually leads on very well to my next question, actually, which is what type of research and workflows is it predominantly used for and can help with?
So I would say it is mostly for looking at disease states or any kind of change within a system. So this is the beauty about metabolomics, is that it is really broad. You can look at any kind of exposure or environmental condition. And as long as you're comparing that to a control, then you can start looking at the broad range metabolites that are changing and look at things that are statistically significant, and you can either get to a point where it's a biomarker or a therapeutic target or something that could potentially be used as a drug. So it is very healthcare oriented, but there are applications in agriculture, in any kind of petrochemical industry. You could go into a very applied range, but for metabolomics, especially for my expertise, does tend to stick more towards the biology and the healthcare side of things.
Right. And you mentioned earlier that obviously your role is involved with working with customers and helping them in terms of issues and challenges they may have, using instrumentation and some of the workflows. So what are the common workflows that people, workflow problems, I should say, that people come to you with, and how can you resolve those particular issues?
So I think some of the main issues that we see are annotation of your analytes or metabolites. It can be very challenging to ID something if you have a fragmentation pattern and you don't have a good database to actually match to, or if it's something that's not in a database and you just can't figure out what it is. We can apply things like molecular networking or other database queries to enable us to figure out what that molecule is, and then put it into context of a biological pathway or metabolic pathway.
Right. Okay. So that's one. Are there any other sort of common problems that people?
Yeah. So, well, as a lot of people know in the small molecule world, when chemical formula gets smaller, you have more likely to have an isomer or an isobar, something that's exactly the same mass. And this is something very challenging with respect to mass spectrometry because it's separated on M to Z and not as much your ability to separate within your chromatography. So your M to Z would overlap, and therefore when you fragment to try and get structural information, you have a convoluted fragmentation pattern. So you can't decipher between the two. And we employ ion mobility mass spectrometry, or our trapped ion mobility mass spectrometry, where we can actually successfully separate isomers and isobars. Lipids, it is particularly good at separating isobars and being able to distinguish the difference between double bonds and double bond positions on your fatty acid chains. It's a powerful tool that we like to employ, and I really like to help customers with developing workflows to be able to apply it to their specific research goals.
Right. So you mentioned it's a powerful tool. So what instruments and software, because I know you do software as well, have Bruker got to help people within this space?
So currently we have our timsTOF 2 Pro 2 that has the trapped ion mobility. This is an LC ESI based system. We also have a Flex system, which has both an ESI interface and a MALDI interface, which you can split between the two of them, which is actually really powerful for being able to do spatial omics and spatial resolution of your analytes or metabolites within a tissue or some kind of biological material that you're imaging. We also have a MALDI 2 system, which is a secondary laser to assist with ionization efficiency. And then we do have our MRMS system, which is our magnetic resonance mass spectrometer. This is functionally an ion cyclotron resonance mass spectrometer for doing, mostly we like to promote flow injection analysis or direct injection type of workflows, because it can be fast and it gives you that fine isotopic resolution and you can do mixtures, but it doesn't do as much. It's slower because that technology, the ICR is just a slower scan speed than a time of flight instrument.
Right. And what about the software though, which connects all the instruments and data? Because I know data is the big thing these days, and interpreting data is actually a huge thing as well.
The data sets are huge, and we see the same thing in proteomics and metabolomics, where data sets are gigantic, and you're looking at gigabyte file sizes, and then you have hundreds to thousands of samples. I have people asking me, can I analyze 10,000 samples? And we can say, yes, you can. You might have to do that in batches, but you can do it. And then we have a software solution called Metaboscape. This is connected to any of our timsTOF instruments. It's connected to our MALDI instruments and our MRMS instruments as well. And we can do analysis based on our either untargeted workflows or even just the flow injection workflows as well. We have Metaboscape is connected to our skills software, which is the imaging software, so they can all be integrated together, so we can garner statistical analysis and even pathway analysis out of that.
Right. Now, what do you, I mean, we talked about metabolomics and obviously the areas it's used for. How do you see the field developing going forward? And are there other workflows or other applications you can see for metabolomics?
Well, I think the biggest thing that I would like to see is improvements down to single cell. Everyone talks about single cell proteomics. It's one of my goals to try and get to single cell metabolomics, where we have the capability and the sensitivity to get down to that level where you're looking at phenotype that would be presented within one cell. That being said, I know we're not quite there yet with that technology. So beyond that, I think the ability to have appropriate CCS libraries that have experimental data are going to be a very powerful tool in the field that will allow us to take an actual compound and be able to identify it or help annotate what it is based on its collisional cross-section area.
So what does CCS stand for then?
Collision cross-section area.
Right.
And it is unique annotation piece of information. So it's an alternative or orthogonal piece of information with respect to MSMS or our accurate M to Z, isotopic pattern, and retention time. So we have these 5 different parameters that we can use to help annotate. So having that orthogonal information is going to really hammer home what that analyte is within a mixture that's really complex.
Brilliant. Well, thank you for that. Well, look, I know it's still early in the morning and you've literally got up to do it. So I have to say you're looking very good for that this time.
Why, thank you.
Better than I would do, I have to say. So that's what we've got time. But if people would like to know more information about, metabolomics and sort of the solutions and help that you can give researchers in that field, where can they get more information?
Well, we do have a very big mass spectrometry section within Bruker's website, www.bruker.com. We have a lot of our software solutions and our instrumentation all presented on there. We are also very much present on LinkedIn and Twitter, so come check us out. Fantastic.
Well, there you go, viewers. If you'd like to know more about metabolomics, and I'm glad I'm saying that rolling off my tongue now, because I was struggling when I first started.
You've practiced well.
I have practiced well. If you'd like to know more about metabolomics, then please check out the Bruker website. I'll put the link above the video. There's a wealth of information there about lots of different aspects around mass spec and the different areas that you can use mass spec in. Lots of application notes, white papers, on-demand webinars, and so on. So please check that out. And again, if you've got any questions for Erica based on what she said today, then feel free to message her directly on LinkedIn. So I know she is on LinkedIn. Or
yes, I am.
You can leave a comment below the video, and I'm sure she'll be able to answer it there. So all this let me say is, Erica, thank you for getting up so early to have this interview. It's been lovely to see you. I hope you have a fantastic rest of the week, and hopefully I'll catch up with you in person, maybe at ASMS.
That would be fantastic. Thank you so much, Rizwan.
Thank you. And thank you, viewers, for watching. And until next time, as always, stay well and stay safe. Bye-bye.